6.3 resistance, reactance, and impedance. So now we have 6 types of circuit for the alternating current. For the first circuit is a pure resistor. Pure means only resistor in the circuit. Alright. Then the next is pure capacitor, means only capacitor in the circuit. And then for the pure inductor means only inductor in the circuit. Next, for the combination of RC circuit means we have resistor and capacitor in the circuit. RL circuit means we have resistor and inductor in the circuit. And the last combination is RCL circuit, meaning we have resistor, capacitor, and inductor. Now, we look for the Phasor diagram. So, we need to draw Phasor diagram for each circuit. Start with pure resistor. So, make sure for the resistor, we need to draw IRMS and the voltage across resistor. And then for the impedance, we can draw the Phasor diagram for the pure resistor, R, and current. So be careful here. So we need to label with arrow. Label IRMS with arrow. Next, look at the Phasor diagram for the pure capacitor. For the pure capacitor, this is the VC with the arrow. And then this is XC with the arrow. So what is XC? XC is capacitive reactance in unit ohm, defined as the opposition of a capacitor to the AC flow. Next, for the pure inductor, L, so this is the voltage across inductor with arrow. And then for the impedance, SL with arrow. What is XL? XL, inductive reactance in unit ohm. Inductive reactance defined as the opposition of a inductor to the AC flow. Next, for the RC circuit, so this is VR with arrow, this is VC with arrow. And then for the impedance, this is resistor, this is capacitive reactance with IRMS. Next, for the RC circuit, so we have VL with the arrow, VR with arrow, and also IRMS with arrow. For the impedance, inductive reactance with arrow, resistance with arrow, and the IRMS with arrow. Now, for the RC circuit, if we consider the value of VL is greater than VC, so the Phasor diagram becomes VL minus VC. So the arrow is upward. This is VL with arrow and current with arrow. Same with the impedance. For the case when XL is greater than XC. So XL minus XC with arrow upward, resistor, and also IRMS. Next, the location of IRMS remain at this position. This position remain at this position, and then this position remain at X position like this. Alright. Okay. So now the direction, which one is lead or lag behind? So actually, phasor diagram, we can read the direction anti-clockwise with the angular frequency omega. So we can draw for each circuit. Alright. Example. Refer to the pure resistor. Let's see. VR and IRMS located at the same position. So meaning for this situation we call in phase. Okay, next. For this one, IRMS ahead. So lead VC or IRMS leads XC. Okay, for this case, VL leads IRMS or XL leads IRMS, and so on. Alright. So now refer to the equation. Okay. So for the pure resistor, the impedance equal to the value of resistance. For the pure capacitor, the value of impedance equal to the capacitive reactance. And then for the pure inductor, impedance equal to the value of inductive reactance. So now we look for the equation to calculate SL. So SL equal to omega L, meaning from this equation, so we can see here SL directly proportional to the omega. So omega equal to 2 pi f. Therefore, XL directly proportional to the frequency. Then, for the capacitive reactance, so the equation is XC equal to 1 over omega C, meaning XC inversely proportional to the omega equal to 2 pi f. Therefore, XC inversely proportional to the frequency. Alright. Now we look for the combination of RC, RL, and RCL. So I want to show you how can we get this equation and also this equation. Basically, refer to the Phasor diagram. To determine VRMS is the resultant between VR and VC. So actually this is VRMS with angle phi. So using Pythagoras theorem, so we get Pythagoras theorem, we get VRMS equal to surd VR square plus VC square. And then using trigonometry, so we will get the value of angle phi. And then same with the impedance. So impedance, the location is between R and C. So this is Z, and then this angle. Alright. So how to find impedance Z? So using Pythagoras theorem. And then for this case, this is the VRMS with angle phi. So this is the impedance Z with angle phi. And then from the Pythagoras theorem, so we will get this equation. But for the combination RCL, so we need to look at the case. For this case, VL is greater than VC. So VRMS here. So to find VRMS, so we use the Pythagoras theorem. And then to determine the angle phase angle, so we find from the trigonometry. So same with the impedance. So to find impedance, so this is the Z. So using Pythagoras theorem, so we can find the value of impedance.